What's up guys, and welcome to this video. This is question 3 of the 2019 supplementary exam, physics obviously, and we're going to cover this question quickly. It's not too long, 23 marks, and it's focused on Newton's laws. Okay, cool stuff. So let's read the question. A child of mass 40 kilograms is holding a stationary dog when the dog pulls forward on an inextensible leash. And the dog exerts a force of 200 newtons so that the leash is at an angle of 30 degrees as shown. Okay, so we've got a nice diagram of this. Let's just put in here that this man here is 40 kilograms. Okay, so we can do the first question, 3.1.1. Okay, so it says, calculate the horizontal and vertical components of the 200 Newton force applied by the dog. Okay, cool. So I'm going to start off by drawing a little diagram of what's happening here. So that's the dog. Cool stuff. And we have this force at this angle. Okay. And we have two components. So we have that component, which is the force vertical, and this is the force horizontal. Okay, and we know that this force has a value of 200 newtons, and we know this has an angle of 30 degrees, and that's going to be a 90-degree angle. Okay, cool. So we can go straight into this. So the force horizontal is going to be using Pythagoras, or not even using Pythagoras, but using some angles. We can say that it is going to be 200, and we want the horizontal, so cos of 30 degrees, which is equal to 173.21 newtons. Okay, and we need to give it a direction, so this force is acting in that direction, which is the right direction. So there we go, and the force vertical is going to be 200, and we want this component this time. We want the vertical component, so we have sine, because that's opposite, sine of 30 degrees, and that gives us a value of 100 newtons, and the direction is down. Okay, so those are our two answers. Let's do that and that. Okay, cool stuff, and we've got ourselves 4 marks. Cool stuff. Okay, now it says calculate the magnitude of the normal force experienced by the child. Okay, so 3.1.2, let's draw a quick diagram of the child. So this time we have the child. So we've got the force of weight acting down, we've got the force normal, which we're looking for, and we've got a force acting downwards like that, 200, and we know that this angle is 30 degrees. Okay, and let's just do this. So force of weight is equal to mass, which is 40 times 9.81. Okay, so now what we're going to do is, because we want the normal force, we're going to take the sum of the forces, and I'm going to take up as positive is equal to mass times acceleration, and up is positive, but obviously this kid is not accelerating upwards or downwards, so this is equal to 0. So what we can say is that the force normal, which is positive, minus 40 times 9.81, which is the force acting downwards. Let's clear that up. Actually, let's just leave that as FW. Okay, minus, okay, so minus that component of the 200 Newton force. And we've already calculated that as 100 newtons is equal to 0. Okay, and substituting values in and taking Fn across, we get the normal force is equal to 492 newtons. And that's our final answer. Okay, cool stuff. So we can now go on. Let me just give myself some space. Cool stuff. So there we go, 3 more marks. Great. Okay, so now it says, given that the coefficient of static friction between the child's foot and the ground is 0.4. Calculate the maximum force of static friction experienced between the child's foot and the ground. Okay, so we know that, let's see, 3 point, how much I'm going to do it underneath. Okay, 3.1.3. What is the formula for our frictional force? Our force friction is equal to our force normal times mu. Okay, we know the value of mu and we just calculated the normal force, so we just need to substitute those values in and we get 492 times mu of 0.4, and the answer is 196.8 newtons. And it does need a direction. The frictional force is going to obviously act in the opposite direction to his movement, so it's going to be acting leftwards. Okay, so there we go. That's our answer for that question. And now we have the last question, 3.1.4. Decide whether the child's foot will slip or not when the dog exerts a force of 200 newtons at this angle. Justify your answer. Okay, so what we need to understand is that the child's foot will slip when the horizontal force is greater. So the child's foot will slip when the horizontal force is greater than the frictional force. Okay, but in this case, our horizontal force equals 173.21 newtons. Our force friction is equal to 196.8 newtons. Therefore, our horizontal force is less than the force of friction. So we can say the child will not slip. Okay, so basically, hypothetical situation, if the force horizontal was greater than the force friction, then slipping would occur. Okay, does that make sense? Yes, because if the force being exerted on this kid that way, if the force being exerted towards the right was greater than the force friction, then overall this child is going to move that way and he's going to slip at his foot. Okay, so cool stuff, and we get ourselves 3 marks there and 2 marks there. Cool, happy days. Okay, 3.2. A child on a skateboard is pulled by a rope and experiences a horizontal force T to the right as shown in the diagram. Great stuff. The mass of the child and the skateboard together is 55 kilograms. Let's put that in. Let's just say mass is equal to 55 kilograms. The total force of 80, so T is equal to 80 newtons. That's not right. You should probably read it. The total force due to friction is 80 newtons, so force friction is equal to 80 newtons. The child and the skateboard accelerate at 2 meters per second to the right. Okay, so calculate the magnitude T. Cool stuff. So we care about that force right there, but we're going to start off as per usual by drawing a nice free body diagram of this child. So we've got T and we've got force friction. Okay, we know this. We know the force friction, so let's do the sum of the moments in the right direction is equal to mass times acceleration in that direction. Okay, sum of the forces. Let's see. We have T positive minus force friction is equal to mass times acceleration. Okay, so therefore we can say that T equals mass times acceleration plus the force of friction. We know the mass of 55, we know the acceleration of 2, and we know the force friction of 80. So tension is equal to 190 newtons. Let's see. calculate the magnitude. Okay, so we don't really care about the direction. So that's our answer right there. Let's put that in red. Cool stuff. And we get ourselves 4 marks. Okay, the force T is increased and the acceleration is measured. For each value of T, the force T is increased and the acceleration is measured for each value of T. All other forces remain constant. Draw a sketch graph for the system showing the relationship between acceleration and T. No values. Okay, so we don't need to give values. Cool stuff. So what are they asking for? We need to show an acceleration versus tension graph. Okay, acceleration we're going to say is in meters per second squared, and tension is in newtons. Okay, so first we have to actually understand the relationship that exists here. Okay, so let's think about this, right? So let's say we had a number, or let's say we have this relationship, right? F is equal to, or in this case T is equal to m times a, right? But this equation only applies when T is greater than 80 newtons. Okay, if T is less than 80 newtons, then the force of friction is too high, so there's no movement. Okay, so less than 80 newtons, this kid is not moving at all, right? So we know that we're not going to start at the origin. We're going to start at some point here. Okay, it's going to be at about 80 newtons, but it doesn't ask for values, so it's going to be somewhere there. Let me also just give myself a little bit of space. Cool stuff. Okay, so no movement. Okay, so when T is greater than 80, the relationship is that the force is equal to the mass times acceleration. Okay, this value is constant, so the force T is directly proportional to the acceleration here because the mass is constant. So after that point, we're going to get a nice straight line. Okay, and that's what your graph looks like. Yeah. Let me just write this newtons over here so it makes a bit more sense. Okay, so I hope you guys understood that. There's a little bit of thinking that had to happen there. But essentially, let me go over it quickly. Because there's friction acting on this person, until we reach 80 newtons, this person cannot move. They're not moving because the force of friction is too high. So if they're not moving, the acceleration is 0. So this graph basically is flatlining the axis. Okay, and then once we reach 80, the relationship that exists is that the force is direct, or the acceleration is directly proportional to the force, or vice versa, because the mass is constant. So we get a straight line, but it does not go through the origin. That's very important. Okay, and then we get on to our final question. So question 3.2.3. Okay, so the question says, sometime later the force T is removed and the child and the skateboard continue to move to the right for a short distance. The skateboard then hits a stone in the path and stops. State and explain what happens to the child. Okay, so so the way I do this is a Newton's first law question, right? There's an external force acting on two objects. One of the objects is not affected, and we actually just answered this question. 3.2.4 is Newton's first law, and we just answered that. Okay, but essentially what's happening is we can say that, okay, so the child and the skateboard will move forward when the force T is removed, because there's no external force acting on the child. Okay, and when the when the stone hits the skateboard, the child will continue to move forward because there's no net force acting on the child. It's acting directly on the skateboard, and the time period isn't long enough to act on the child. So basically, the skateboard stops, but the kid continues to move forward as he experiences, or he or she experiences, no net force. Okay, yeah, and that should get you your 3 marks. So yeah, thanks for watching, guys. I hope this was useful. So we've been through that question, and in the next video we'll probably go over question 4, work, energy, and power. So thanks for watching.